Alright, this is example 3 from our notes packet, and here we are trying to determine whether the graphs of 3x plus y equals 12, y equals 1/3 x plus 2, and 2x minus 6y equals negative 5 are parallel or perpendicular. As a quick refresher, parallel lines have the same slope but different y-intercepts. So when we talk about their equations, parallel lines would look something like this. Y equals 1/3 x plus 2 and y equals 1/3 x minus 2. So notice you see that your slopes are the same but your y-intercepts are different. Okay, so then we also want to talk about perpendicular lines. So if two lines are perpendicular, I'm going to take that same example, y equals 1/3 x plus 2. And for perpendicular, we want to take this fraction of 1/3 and we want to take the reciprocal. So the reciprocal would be 3 all over 1, but then we also want to take the opposite. And since 1/3 was positive here, we want to make this number negative. So we have negative 3 over 1 x. And for perpendicular lines, you can have the same y-intercept or they can be different. So an example of two lines that are perpendicular would be this case. Of course, we would simplify this to y equals negative 3x minus 4. So as you can see, these two lines here are perpendicular because of their slopes are opposite reciprocals. So the first thing it wants us to do is to graph each line on the coordinate plane. If you take this first line, it's a little bit easier to graph using the intercepts. Remember, if you're going to solve using the intercepts, you take 3x and you set that equal to 12 and solve for x. You get x equals 4. If you want to find the y-intercept, you take y, set it equal to 12, and that's already solved for y, so the y-intercept would be 0, 12. And then through any 2 points you can draw a straight line. This equation is a little bit more difficult to solve for the intercept, so I would actually go ahead and solve that equation for y and get it into slope-intercept form. When you do that, you get y equals 1/3 x plus 5/6. Now 5/6 is a little bit more difficult to graph on the coordinate plane because it is a fraction. If you take 5/6, that's a number that's really close to 1. And if we take a look at this next graphic, you'll see those three lines graphed. So again, this red line, y equals 1/3 x plus 2, represents this equation. 2x minus 6y equals negative 5 is the same line that we just solved for there. So as you can see, the slopes of those two lines are parallel. So indeed, this line here and this line here are going to be parallel. Finally, this blue line here, this 3x plus y equals 12, that is this equation here. And if we solve that equation for y, we get y equals negative 3x plus 12. And as you can see with the slope of negative 3, that is what we talked about down here. So it is the opposite reciprocal of y equals 1/3 x plus 2. So if we're talking about parallel and perpendicular, we have that these two lines here, let's just go ahead and give them numbers, 1, 2, and 3. So we would say that lines 2 and 3 are parallel, lines 1 and 2 are perpendicular, and finally lines 1 and 3 are also perpendicular. So the answer from this, it says, from the graph you can see that y equals 1/3 x plus 2 is parallel to 2x minus 6y equals negative 5. They are parallel because they have equal slopes or the slopes are the same. 3x plus y is equal to 12 is perpendicular to them because the product of their slopes, 1/3 and negative 3, is negative 1. Okay, so checking your progress, it says determine whether the graphs of y equals negative 2x plus 1 x minus 2y equals negative 4 and y equals 3 are parallel or perpendicular. As you can see from the graphic to the right, you have all three lines graphed here for you. Remember, y equals 3 is a horizontal line. If it was x equals, that would be a vertical line going up and down. The red line here is x minus 2y equals negative 4, and the blue line is y equals negative 2x plus 1. So as you can see here from your answer choices, what we want to do is we want to solve the x minus 2y equals negative 4 for y, and we're going to compare it to the slopes. So we know that the line y equals 3 has no slope. So that is a horizontal line. There is no x term with this. If I solve x minus 2y equals negative 4, the first thing I would do is I would subtract x from both sides, which would leave me with negative 2y equals negative x minus 4. And if I divide everything here by negative 2, the result is y equals 1/2 x plus 2. And as you can see here, y-intercept of 2, go up 1 and to the right 2, and that gets you to your next point. So now really all we want to do is compare slopes. So here I have no slope. Here I have y equals 1/2 x plus 2, so my slope is 1/2. And then finally the last blue line, that equation is y equals negative 2x plus 1. So if I'm comparing my slopes, 1/2 and negative 2, a way to check to see if they are perpendicular, we multiply those two numbers together and the product should be negative 1. So I'm going to take negative 2, remember negative 2 as a fraction is negative 2 over 1, and I'm multiplying that by 1/2. We multiply fractions straight across, so negative 2 times 1 is negative 2. 1 times 2 is 2, and negative 2 divided by 2 is negative 1. So we know that the red line and the blue line are perpendicular. They do form right angles. Okay. So answer choice A, y equals negative 2x plus 1 and x minus 2y equals negative 4 are perpendicular, and none of the lines are parallel. Well, based off of the graph, you can already tell that none of the lines are parallel. So you can go ahead and eliminate none of the lines are parallel or perpendicular, and none of the lines are perpendicular. Well, we just proved that, so C is eliminated as well. So our answer choices are between A and B. Correct answer here is A. For our next portion of our notes, it says, given two equations in standard form, determine whether the lines are parallel, perpendicular, or neither. Remember, if they are parallel, they have the same slope. So are the slopes the same? If your answer is yes, then they are parallel. If they are no, you want to know if the slopes are opposite reciprocals. This will help determine if they are perpendicular. If the answer to this question, are the slopes opposite reciprocal, is no, then it's neither parallel or perpendicular. If your answer to the question, are the slopes opposite reciprocals, is yes, then your answer is perpendicular. So again, it says write each equation in slope-intercept form. So the first thing we would do here is we would subtract 3x to both sides. So we have negative 3x, negative 3x. And I'm going to write this off over here to the side. So negative 4y equals 3x plus 12. Sorry, equals negative 3x plus 12. Divide both sides by negative 4. And our result, negative divided by negative, is positive. So this is 3/4. And 12 divided by negative 4 is indeed negative 3. For our next equation over here, 6y equals 8x minus 12. X is already on the opposite side of y, so really all we have to do here is divide everything by 6. When we divide everything by 6, negative 12 over 6 Negative divided by positive is negative. 12 divided by 6 is 2. 8 over 6, that is a fraction that reduces to 4 over 3. So, when I take and I put in 4 over 3 here, notice your slopes. You have 3/4, you have 4/3. They are reciprocals of each other, so that means that 3/4, if you flip the numerator and denominator, you get 4 over 3. However, the missing piece here is this is positive and this equation is positive, so they are not opposites. In the next problem, write an equation in slope-intercept form for the line that passes through 4, -1 and is perpendicular to the graph of 7x minus 2y equals 3. So in this problem, if we're going to determine that the line is perpendicular, we first need to solve this equation here for y. So the first thing that we want to do is take x and move it to the other side. So in the equation 7x minus 2y equals 3, subtract 7x to both sides. Know that when you subtract 7x to both sides, this is now eliminated because it makes 0. So the result is negative 2y equals negative 7x plus 3. From here, the only thing you have to do to get y by itself is divide by the coefficient in front of y. So I need to get rid of this negative 2 by dividing by negative 2, divide by negative 2, divide by negative 2. When you do that, this negative 2 and negative 2 cancel out because it makes 1, so it's really 1y equals, and then we're going to split this apart. Notice in this next part though, there is a typo. So you do get y equals 7/2 x, so a negative divided by a negative is positive. However, a positive divided by a negative should be negative, so this is not positive, it's really minus 3/2. So we say that the slope is 7/2. So the slope of the perpendicular line is the opposite reciprocal, so if I take 7/2 and I flip that fraction, 7 goes to the denominator, 2 goes to the numerator. So again, you see that result here. And then, since this number is positive, this one becomes negative. So now it just says find the equation of the line that is perpendicular. So we are definitely going to use that slope. So we're going to substitute into point slope form. So y minus y1 equals m times x minus x1. Substitute in for your slope. Remember the point that we were working with was 4, -1, so we're going to take the opposite of 1 here. So a negative times a negative becomes positive, so in our final equation this part would be positive. Our slope we said was negative 2/7, we substitute that in for m. And then since 4 is positive here, we take the opposite, and that's where it becomes negative 4. So y plus 1 equals negative 2/7 x, negative 2/7 times x minus 4. So now if we use the distributive property, you get negative 2/7 times x, and then negative 2/7 times 4 becomes, times negative 4 becomes positive 8/7. From there, all you have to do is you got to get rid of this plus 1 by subtracting it to both sides. Remember, this is eliminated. Whoops, that is not eliminated, but on the left side it is. So when you go to simplify, you get y equals negative 2/7 x plus 1/7.